Derivative of e to the x is e to the x. Very nice. ln x is 1 over x. Very nice. If they have function inside, you multiply by the derivative of the function inside. Chain rule. And then we practiced ln x, 35 ln x, 35 over x. Constant 0, 35 inside of the log, that's chain rule. Polynomials, exponentials, we practiced that. To the cosine, product rule. I did this weird example, log of secant x plus tangent x. Still, 1 over everything. So you don't get too scared about it. You do 1 over everything. And then times derivative of the function inside. We even did square root. So I did lots of examples and explained the difference between 13 being inside versus 13 being outside. Like so. So one thing I did not mention yet is how to use more properties of log to make differentiation better. That's example from your homework. 25, if you want to know. Y equals 4x minus 4 squared times 5x squared plus 2 squared. Find y prime. What? This is horrible. Look at this. It's going to be product rule and then chain rule for each time. So people actually use log in those cases as well. You don't have to. You can do product rule and chain rule, but it's faster if you use log instead. And the idea is you're going to use log to the both sides, left-hand side and right-hand side, and perform logarithmic differentiation. Oh, then I should have shown in the previous topic. It's fine. Logarithmic differentiation. Now it's kind of in 2 different videos, but it's okay. You perform log to both sides. ln y, or you do the way we mentioned, second way actually will work well too. ln y will be ln of, and let me color code everything because that's going to be super fun. People like, her definition of fun is not the same as my definition of fun. 5x squared plus 2 squared. And now you use properties like a pro. Because it has product, it has powers, that is laws of logs. Step 1, put ln to both sides. Step 2, use laws of logs. ln y equals, first I see product inside of the log. Remember, log times log has no formulas, but log of the product works with the product so well, it breaks it into a sum. It's going to be log of the first guy plus log of the second guy. Does that make sense? It works with fast processes and break into slower ones. Product is fast, so it breaks into the sum of 2 logs. The first one is 4x minus 4 squared. Bless you. And the other one, 5x squared plus 2 squared. And then there is one more thing to do. Equals 2 goes down, where is it? Goes down, 2 goes down. So that's also convenient. It takes powers inside of the input. So let me put parentheses. It's in the input. And puts them down. 2 and 2. ln 4x minus 4 plus 2 ln 5x squared plus 2. And now you differentiate all of this. Perform implicit differentiation. Implicit differentiation. Left-hand side gives you 1 over y times y prime. 1 over y times y prime. Ask me, does it you understand why it's 1 over y times y prime? Derivative of ln y is 1 over y. And then times the function inside, y prime. And now you differentiate logs. People who got distracted with your phone or computer, do you want to check it out? 2 log of 4x minus 4 becomes what? When you differentiate it.
2 by 4x minus 4.
2 by 4x minus 4. Do you know why it's 2 over? Because it's 2 times 1 over input. And then chain rule says times, that's chain rule. Derivative of the function inside, but derivative of 4x minus 4 is just 4. Does that make sense? Plus, and then log of the, did I lose a power? No, I think it's fine. And then log of the 5x squared plus 2 gives you 1 over 5x squared plus 2 times derivative of the function inside, which is 10x. And this is almost the answer. The answer will be everything times y. So step 3, multiply by y. And now I'm going to skip one step. I'm going to multiply everything by y, and I will have y prime equals blah, blah, blah. But y is given. Y is its original function. 4x minus 4 squared, 5x squared plus 2 squared. Like so. That will be the answer. Y prime equals blah, blah, blah times y, blah, blah, blah. So right hand side times y. And right hand side, RHS, is right hand side whatever we were just differentiating. Yes?
On tests of quizzes, would we be taking points off if we gave it in terms of y?
Yeah, that's a good question. If you forget to change your y to the original, you'll have points off. Let's do so a little bit. You're supposed to remember to do it. Unfortunately. That's a good question. What do you think about this? Crazy, weird stuff going on?
Just a bunch of rules put together.
Bunch of rules to put together. Exactly. And that's kind of what is hard about it. Okay, let's move on to the tricks.